Okay, so just to kind of recap what we just saw, HTTP requests, you're not supposed to remember exactly what I typed out before. The reason I thought it was important to see the text format is, one, HTTP is very approachable in the way that it's not a binary protocol. You don't have to sit all day and figure out what does different bytes mean. It's just text. So you could, in theory, write your own HTTP server from scratch without knowing anything about the operating system, but to be able to connect to a network and be able to talk over TCP, which is what HTTP does, you'd need to know how to open sockets and all that kind of stuff. And that's kind of complex, so that's why we kind of just forget about that and use a higher level module. And in a moment we're going to use the core HTTP module in Node.js. But just to recap, HTTP requests, it's very important. It starts with a verb, then it has the URL part, or like the path name of the URL, and then it has the protocol. So in our case, or for all modern purposes, the protocol is always going to be HTTP 1.1, and then it has a set of key value headers, which none of them are required for most HTTP servers. And then actually on the HTTP request, you might have a body, because if you do a post, for example, from a form, then all the data that's typed into the form is encoded and put into the body of the request. So both responses and requests can have a body part as well. And they are separated. The head part of the request is separated from the body with an extra new line. And the response is also very simple. The response has the protocol first. The reason the protocol is first is because then any browser receiving text can see immediately, okay, do I understand this protocol, or can I terminate the connection or try to do something to improve the connection. Then it always has a status code and a message associated with the status code. And then it might have a set of headers as well. Then a new line to separate the body from the head part. And that's HTTP. The reason I also kind of want to highlight the protocol thing is that right now the most ubiquitous version of HTTP is 1.1, but HTTP 2.0 has been out for a fairly long time now, and actually with the latest version of Node, HTTP 2 is a core module, so you can do HTTP 2 requests. HTTP 2, however, is extremely complicated. It has a lot of very complicated features. It's a binary protocol, so it means the whole exercise we just did with typing things out by hand, you cannot do that. And also it puts a lot more work on both the client and the server regarding how you're going to pass all the different things coming back. For example, here, for each server, we can only do one request at a time. What the browser does, though, oftentimes is that it opens more than one connection to the server. So while you get the body, it can load, or like after you get the initial body, it can load the fav icon, and it can load images and JavaScript and all that simultaneously. Right now, with the HTTP server we just saw, you can only do one request response at a time. So it always goes like request response, which means that if one of the pages is very slow, then that's going to hold up all the other resources you might want to load. With HTTP 2, there's something called multiplexing, where you can do multiple requests across the same socket, and like all this complicated stuff. Just want to say, it's out there, be aware of it, but we're not going to work with HTTP 2. Just going to look at my notes here. Actually, another thing I want to show is I want to show some more things about URLs, because we have only looked at a very, very simple URL, right? We have looked at one where it's hang on. I want to show you something after, but first we're just going to we have only looked at a very simple URL, one where we have just a single page, Hack Your Future. But if we start the server again, URLs are much more complicated than that, right? You can send query parameters, you can have the hash part of the URL and all this stuff. So I want to show you what it looks like. So for example, up here, let's say we also have some query parameters. So we can say, let's say something like this, and then we might also have the hash. It's called the hash part of the URL. So this is something, for example, if you have an ID on an HTML element, you can make the browser scroll to that element by using the hash in the URL. So we're just going to put in the hash part here. Okay, and if we request that from the okay, so now we did the HTTPS thing again. Let's just go back. So we're going to request this URL up here. It says HTTP, host name is localhost, port 8080. The URL is hack your future. Then we have a query string with a parameter equals value, and then we have the square and then hash. And then if we request this from the server, you can see what's transferred up here is that the URL is actually just a string. So the query parameter, the query string here obviously has some structure. We have key values, but it's not like that's encoded anywhere special in our HTTP request. It's just part of the URL. You can also see that it's missing the hash part, and that's because the hash part never leaves the browser. It stays with the client. Because the way it was designed is that in the beginning, the hash part was just there so you could scroll to the ID of an element, so you could kind of have anchors within a HTML page. Today, it's kind of also used for a lot of other things, for example, client-side navigation, like deep linking, that kind of stuff. But it means the hash part is never transferred to the server. And that's kind of just what I want to show, that the URL has a lot more. The URL is kind of like a way to serialize. Serialization means take a very complex piece of data object and make it into something that's very simple. So here we take something that has a lot of structure. It has, if you were to represent this as a JavaScript object, maybe you'd have a host name property and a port property, and maybe a path. You maybe have a path property. And maybe you represent the query string here as another object with keys and values, and maybe have a hash part. But obviously you cannot send JavaScript objects over HTTP, at least not as built into the protocol. So you take that object and you turn it into a string, and then URLs are like the predefined format. So that was another thing. Also, I kind of just quickly glimpsed this graphic. I wanted to show you what I was talking about before with application layer. So what we just, this is kind of called the OSI layers. It's kind of like a standardized way to describe the different parts of of the networking stack. So you can see down all the way down the end we have the stuff that was talked about before with wide area networks and that kind of stuff, like how is the physical infrastructure, the cables and stuff. And then it kind of builds up from there. And what we just did, Netcat is a debugging tool for debugging the transport layer. So we were talking over the protocol called TCP. There's also another protocol called UDP, which we're not using. UDP is often used for voice over IP and for data streaming and that kind of stuff, video streaming. And then HTTP, you can see it kind of lives up here. They call it the presentation layer. I guess that's true, right? I don't know, I often call it the application layer. I guess that's kind of where it's kind of ill-defined. Where do you put HTTP in this stack? So I just wanted to quickly show that this is
usually
kind of
like in a new modern networking, they also talk about the four layer instead of 7.
Okay.
Because it's getting harder to have a precise division. So what's happening that sometimes presentation application is the same, or data link and physical, or so they try to simplify and say they're actually 4 layers for teaching purpose. But those 7 layers out there, maybe are even more. But from a mental model of the network, they try to simplify and actually 4 layer. This is I would say the old approach now, which is still very valid.
Like the way you can process it, this is that whichever layer you're working at currently, like we're working at level 4 right now, right?
Yeah.
So that layer is kind of abstracting everything underneath. It's not like there's not more things going underneath the surface there, but it depends on the tool that you're using. So at this stage, we're just seeing something at level 4. When we start using APIs within Node, could say that we would slightly go even more up.
Yeah, like I'd say when we start, we will be working at this layer, the application layer. But yeah, also another thing, like what TCP does is that if so these messages over here, or like this text, is wrapped up into something called packets, and these packets are sent over the network, and they go through the router, they go through switching, they go through peering and all this stuff. So we can actually also look at, you can see where your package actually go when they go on the network. So for example, now we are in Denmark, we can there's this tool called traceroute that you can use to see where does the packages go, or packets go on the network. We can try and see who touches our packets before we talk to dr.dk. So you can see actually the packets go through a lot of different layers before they eventually hit dr.dk. So you can see this is our router, the local router. Then it goes through a couple of hubs. So these are probably peering centrals before, or maybe this is the local switch, and this is probably a peering central, and then we eventually hit dr.dk down here. And you can see it was kind of quick. We got there in about 4 milliseconds. You can also see that the packet here was actually kind of, I think it's multicast, because there's 3 different IP addresses responding to the packet. You can just see that some of them were slower than the others.
Yeah.
So, but this is all like very low-level networking stuff. I just wanted to show.
And of those 3 disciplines,
It's actually just 2 of them, and I think it was doing a race between them.
yeah,
So there's some reverb here because this one replied twice.
Yeah, they were racing.
So
And that one, yes, yeah.
you remember promised race, for example. So this,
Yeah, no, this is really networking. But basically, the network, it's a mesh network. It means that nodes are connected to multiple nodes. So think about a lot of routers scattered through the city, and that there's links. And obviously, some nodes, some packets can take multiple paths, and this is good for resiliency. So if a packet gets lost in one track, you still have another one. So this multi-path, you could see there that at some point they were sending 2 ways, and one of the 2 was quicker, and that one that was carried on. But this is obviously this is really down into the networking part of the. It's a bit out of the NODE.js teaching, but it's good that it's showing, because it's I think like my guess that he's trying to show what's really happening all the way through. So that's why he's showing those things, but it's not part of the curriculum.
No, it's just
and it's just interesting information, but you don't need to know those things, because the way we are touching now are just just keywords for you.
basically develop an appreciation that the language that you're using is giving you such a high-level context that you won't have to deal with all these things. But no matter what language you use, that's actually what's happening always behind the scenes.
Think about when you think about internet, you think something that is there and works. What is really internet? Then you start to think, well, okay, what's this, like something magic box? Or when you start to disassemble what's really internet, then you start to get into the network and infrastructure and protocols and blah blah blah.
Reverse engineering.
No, it's not reverse engineering. It's a much it's a picture. How much high resolution you want to have, right? So more you disassemble the internet part, and more you start to get in the nitty-gritty things that we don't want to get into. Because then it will really change the name of the course and something else.
Okay. So that was all fun networking stuff, but that's not what we talk about. We're going to talk about Node, right? So I think we might as well just jump right into it and see how do you build a HTTP server in Node. So I have my terminal over here. I'm just going to make a new folder. So we are going to make a URL shortener, so that's just what I'm going to call it.
should everyone follow what you're doing, or they should?
Yeah, I think it's a good idea if you follow along now, but don't get too bogged down by your notes. We're gonna have a 15-minute break, and then you can get some food and catch up there. And you can always like interrupt at any time and ask questions.
But we try to make it we try to build it all together.
Yeah, exactly,
Somehow.
exactly.
Like,
Everyone.
We don't go super quick, and we try to build it all together. I mean, create a folder, and they don't need a transpiler, right?
No, we're just gonna do simple
The
node.
simple, yeah.
Very simple node. Okay. Just gonna make a index.js file.
So touch is for create a file.
Yeah.
You might not have it in Windows, unfortunately.
Yeah. You can also.
They're using the Windows, so that.
I mean, you create. Did you see the video?
No, I didn't.
Yeah, well, that's why I tell you. But
if you guys have Git bash, you can use that, and that would have Linux Unix
Yes,
commands
true.
there. Okay?
Yeah, that's probably it's best.
Make your life easier.
Yeah, use Linux, use Git bash because
Oh, I know.
I mean we're gonna jump straight into an editor very quickly.
You might have it installed as well.
I mean, you can also like create a file by
Yeah.
right-click, you know.
You can just open VS Code or Atom or whatever you're doing. Okay, so everyone is done.
Yeah.
Just gonna make the index.js file, and we don't need anything but that so far. Cool. The HTTP server and client module in Node.js is just called HTTP. So I'm just going to import HTTP. Cool. And of course, just check that it works. Everything's working. Is everyone with so far? Cool. Okay. So I'm just gonna show you what's on this object. So another nice utility to print out what objects look like is this console.dir. I think it also works in the browser, but with console.dir it has a second argument where you can say, okay, colorize the properties, and also you can limit the depth. So if you have a very nested object array, you can limit how deep down it prints things. So I always use that. I just have it as like a snippet in my editor to make it easier to look at stuff. So if you print out the HTTP module, you can see there's a lot of stuff going on in here.
Yeah.
If we just limit it, I'm just going to limit this to 1. Does that not work? 0? Okay. If you give it 0, it's just going to print out the immediate properties. So what we're going to use today is just this create server function, which will allow you to create a new HTTP server. But I also want to bring your attention to the two array or like constants in the top, the methods array and the status codes. So methods encodes all the HTTP methods that the node HTTP parser accepts, and status codes has like an object where you can look up the you can give it a number and it's going to give you the response message. And both the methods and the status codes have a lot of the methods has some non-standard HTTP methods in there as well, because Microsoft wanted to be a snowflake and invented their own HTTP methods for a lot of their products, and likewise with status code. You can have a quick look. Let's just we do HTTP dot. Look at the methods in here. You can see there's a whole bunch of methods. So if you look up here, the only ones that are actually standardized HTTP methods is delete, get, head. Then we have to move down. So then we get to options, patch, post, and put, and all the other ones are non-standard HTTP verbs. So I don't know what these are used for. Different ones, like some of them, you can see there's one here for talking to Microsoft Exchange servers for like making calendars, make activity, and these kind of things. And there's a lot of different other ones, but yeah, we're not going to use any of those. So I'll just clear this out. But okay, that was just, I just want to have you appreciate that the HTTP module has a lot of have a lot of functionality in there for doing different kind of stuff as well. So we're gonna jump straight in and make a new server. So I'm gonna make a variable where I put in the server, and then I'm gonna call http.create server. And http.create server takes we're gonna use the version that takes a single argument, and that's a function. And this function is the one that's called every time someone does a request to our server. So it's gonna be called with 2 arguments, and normally these arguments are called rec and res, and that stands for request and response. One thing to be aware of here is often when people work with callbacks or promises or whatever, they use res for both response and result. So if you're not careful, you might by accident override this variable on and on again. At least I've had a lot of bugs like that where you kind of have them nested and then you override it and stuff. So just be aware of that. And
by the way, like init is using like the ES5 style of coding, but if you want to use let or const and what do you call arrow functions or whatever, that's fine.
Okay.
Don't, yeah.
Don't limit yourself.
We understand.
yeah, you do whatever you want. Okay, we're just going to skip what this function does, and there's 2 parts to creating an HTTP server. First, you need to create the server itself, and then you also need to have this server listen. The listen function has a lot of different versions. We are going to use the simplest one, which just takes a number for the port we want to listen on. So we're just going to do 8080 like last time. And once you have that, you can try and run it. And then you can, if you are in git bash, I'm just going to make this bigger. In git bash, you have curl. You can use curl, and then you can make a request to localhost 8080. And if you do that, you should see nothing happening.
Yeah.
It says firewall is blocking.
So that might be a Microsoft thing. When you start the server, does it ask you to open the firewall or something like that?
Now it's saying
Maybe you need to run your terminal as administrator or something. It's very important. Another convention with ports is that if the port has to be larger than 1024, every port below that are special ports that are reserved. So you need to be an administrator, or on Linux you need to be sudo to be able to bind. It's called binding when you listen. You need to be able to. You need to be administrator to be able to bind to a port less than that. So that's why you always see, for example, people do. Normal HTTP is port 80. So when you do development, you do 8080 because that's an unrestricted port. Did you manage to connect? It should just be hanging, but this is a good sign. If it's hanging, it means that curl, which is a command line utility for doing requests, was actually able to connect to the server, and it's just waiting for a response from the server. But if you can connect, then we are ready to progress to the next.
So who can connect? So you can't connect?
It's better to say who cannot connect. Okay. Yeah, that's good. That's good. Then you need a.
Why do I have this?
You can see when I start, you need to have a second terminal window where you can run curl. So if you have git bash
Oh, I
installed,
have fancy curl.
then start git bash,
that's also fine.
Can you also do curl?
and then do as I did, curl localhost 8080. See what happens.
Again, this one.
This one?
This one. Can I have one more? Then do curl.
And it's working.
Good. No, just
That is the
yeah,
that
but
is on the basis.
yeah, but it's good. I'll show you.
This is going
I'm on
this is
I'm on Linux right now, right?
Mhm.
Should I also use curl to?
You can do whatever you want, but yeah, curl is. I mean, we just need to make a request. So curl is a way to make a request. Yeah, you can also use your browser or whatever.
You can also change it actually.
Yeah, I think so. Now it's okay. This is the only part of power script.
Not currently.
Local should also hang.
Fine. I tried that.
This should hang.
Yeah.
Yeah.
You can also change the same folder.
Same folder.
You can make
This one.
yeah, you can also make this.
Colors one.
Local state. That's good.
Yeah, that's good. Cool. Okay. At least you three are connected. Is anyone not connected?
Is it okay?
No, something happened.
Connection refused.
Yeah. So there's an
2 minutes, exact 2
problem on
minutes.
here. So I don't know if there's space up here.
Yeah.
You cannot have a space.
In
after
exact 2
the file.
minutes, and then it says like empty.
Oh, so you should have seen the server at the start. Save the file. Start. You have to start the server again by running NODE.js or index.js. Okay. Run that. Hanging, okay, and then run curl.
Good.
Yeah. And you should see the server hanging. Yeah. Good. And nothing happens. That's good. So because nothing happens, it means it was able to connect to the server, and now, kind of like when we did it by hand, it's waiting for the server to send a response back.
So first we have to
Start the server. Yeah.
Okay.
Okay, so everyone is able to connect to the server now. Cool. Okay, then now we are gonna make the. I'm gonna stop the server. You can also stop the server on your computer. So everyone stop their server, and we are gonna implement the server. So what I'm gonna do here, you don't need to do the same, but I'm just want you to show what's inside this request.
Yeah, the timer also starts, so it shows it's connected.
Yeah.
Yes.
So you don't need to do this, but just follow along up here. Now every time we get a request on the server, I'm just gonna log out what does the request as a JavaScript object, what does it actually look like?
How to stop the server?
Control C.
Yeah, Control C, you can stop, kill it. Okay, so now I just, I made a new request to the server, and you can see now it prints out all this stuff here. There's a lot of stuff going on, but I just want to bring your attention to some of the information being transmitted. For example, the HTTP version that we wrote by hand is encoded in here. You can see there's an object of headers. There's also a URL, which is just a string. We have the method, and then because this is a request, not a response, the status code and status message are both null. So just some interesting stuff. I just want to quickly show you something else. Start the server. Curl, the reason I'm using curl is because with curl we can add some command line flags to make it show us what is it actually sending to the server. So VVV is like a convention for command line tools to say I want you to be verbose, and the more V's you add, the more verbose it's going to be, the more output it's going to give you. So if you print out this, then you can see this is actually what our what the curl command is sending a get for the slash URL, Here you have the protocol. You can see it sends the host header, the user agent header, and a sensor accept header, and now it's waiting for response. And you can see this is mirrored over here in the JavaScript object. Cool. So I'm just going to remove this for now. The response, this request and response objects are something very special in Node.js. They are what are called streams. So one thing I didn't show you when we did the netcat thing is that the data, the text data comes in, it might not all come at once. It might come in different packets. So it might come split up totally. And that means that the server has to put back together all these packets coming over the network. So that's why you have a streaming abstraction. So for now, all you need to worry about is that the res object has a method called end, and that just means I want to send, this is the last package I want to send. After I've sent this, the response is done. And this command, it takes a string or a buffer. So we're just going to set it a string.
You're using Visual Studio, you should be able to see the descriptions of the methods being used, like listen and then all same place, right? When you hover over, just to get an idea.
So if you start the server again and make another request with curl, you can see that the Node HTTP server actually filled in some response headers for us. So put in update, put in something called keep alive. This is where the browser can, or like the client can reuse the connection again and again. And it also set the content length for us. So it set the content length for ELF to 11, and 11 is the number of bytes that hello world is. And since the server is still running, we can do this over and over and over again, and it will always respond the same thing. Cool. But of course, there's other things you can set on the response as well. One thing that we should set, it's set for us by default, but if we want to say, for example, the URL you just requested is not found, we want to send a 404, we can set the status code, and we can also set the status message. And that's where this comes into play. The big constant object that I showed was on there before. Because if you do this, status codes, then you can see it gives us the standard status message.
I think this at least is also the default behavior, right? If you don't set the status message yourself, it will still
set 200. Yeah, exactly. That's what we saw over I don't have the output anymore, but curl showed us it's going to set 200. It's going to set the status message because those are required for the HTTP protocols. But if you do this, start the server and make a request, you can see it actually sets 404. You can also try and do it in your browser. And you should get hello world. And if you look in your DevTools, and look at the document, you can see that you actually get a 404 back. Okay.
You guys understand what's going on, or we have a question right now?
Yeah, we have a question.
Yeah.
Please explain this status message, status code 404. This thing.
Yeah. Okay. So let's try. I can just run a node instance over here. So this is the code we have up here. So status codes is a big object that has as key the number for the status. So as key has the status code, and then as value it has the message, the standard message. So all of these status codes are standardized, and you can look them up on Wikipedia. You can look up it's called the RFC request for comments. That's a document that defines exactly how HTTP is built up and how it should be parsed and all this stuff. You don't have to look at any of that, but you should know some of the standard ones. So you can see here's the 301 that we got back from Google. We requested google.com. It says move permanently. You can see we have 200, which means okay. It's the most standard code. You can also see we have 404 down here, 400, 401, like all these codes. And we also have the 500s, which are when there's a server error that the client cannot do anything about. So you have all that stuff in there to help you out. Okay.
And the status code is what the server sends back to the client when the server gets a GET request, right?
Yeah. When it gets any kind of request, you set the status code and the status message. That's required by a protocol. Then, of course, you can also set headers like we did before when we wrote them out by hand. And I want to show you that when we make a request to the server, the server sends back a content length. I don't know if you remember, but when I wrote the request by hand, I also sent back a content type, which is it's not required, but it's good practice. So let me just show you how we do that from Node.js. So there's different ways to do it, but the best practice is to use the method called setHeader. Then we take the key and the value, and in this case we are sending text. So that one is called text/plain. These over here, these content types, there's a few of them that you want to know by heart. For example, text/plain or text/HTML or application/JSON. But you can always look them up on Google or on MDN. They're called meme types. It's not important that you set these, but it gives the browser a clue about what is it you're actually sending back. So for example, if we are sending images, then we might send image/PNG, for example. Or if we are sending video, we might send video/MP4 or something like that. So if we run the server now and see what we get out of curl, we actually get the right content type back. Oh, I probably wanna. I can remove this also. Oh, let's make it a. Nice. Remember, every single time you make a change to the JavaScript file, you need to stop the server and restart it again.
Haven't got. Ding.
There's a command to make watch up.
Okay, so if you could use something like node mode, which will just watch profile changes and reload, or if you use scaffolder later, I think Mark also has put a watch command over there, so we can arrive on that later. For now, it's simple enough to just do that. But I think, like, if you look at this code, you should observe a few things compared to what we were doing with Netcat before. Right?
You have to restart.
Is it working?
I hate blocking.
Why does it lock?
It's working. Is it working?
Stop. Oh, if you click over here and then press Control C, then you stop the server. Then you can restart it.
Ah, here.
Oh,
Yeah, yeah.
connection. Repeating the connection. connection with
So you have a JavaScript error somewhere. Because you have a space between the method call and the brackets here. Oh, sorry.
But you, is
You're not allowed to have space after the set header.
yes,
Can you show me that? Nope. Yeah, that's why no server, no connection.
What do you say?
There's a space. You have a
Can
space
we
in there.
call from
You're not allowed to have space.
Why is it empty? Yeah, because you
Okay,
have a
it's working.
header in your status codes.
I can check that.
No,
Try and run
that's
code.
that's that
Yes.
because it's status codes.
Okay, and you have another JavaScript error.
So,
Okay, so do you understand that error?
input
Status code. Typo.
and but you need to do curl VVV to be able to see the responsibility.
The server starts just right when I try to ping it. This happens. It must be valid. But isn't it?
You don't need a colon here.
Oh, no, sorry.
So
I started this server, but it's
Is it hello world?
Yeah.
Now it's just because the version of curl that is installed in Git Bash has all this extra output. So that's why it looks a little bit messed up. But yeah, and you can see the headers up here. You have a typo there, but it doesn't matter too much. You can see text plan.
Yes.
It's text
Text.
plain.
Oh.
I was in the wrong.
But I mean, yeah, it works.
So if I give any kind of content, then
yeah, so it's working.
Mm-hmm.
So when
text.
Yeah, yeah,
If it is image or
yeah, exactly.
curl, yeah, but it says yeah, received. Okay, not found.
so for every time then I need to stop the server.
So what we have to do?
For now, at least this.
Debug this.
Now we're keeping it very
Now
simple.
it's, yeah.
But if
So
you
it's exactly the
some
same.
people have a program that's every time the file changes, it restarts the server. Some people do that. But this is just very simple.
If that change, you would also see the change over here. Yeah.
Doesn't your scaffold restart the server when you run watch?
No, you need to add something else.
Okay.
That will
So instead of text, if I
it
use
will recompile.
image, then
But it will not stop
Well,
the start.
this header
Doesn't
up
the
here
ru-
is
watch
just a
recompile
suggestion
every time you-
to the
Yeah, it will
browser.
recompile, but
The
will
browser
not
can do
stop
whatever
the
they
start.
want, but you're telling it, okay, if you
You wanna
say,
do
for example, if you
when I
send it
recompile,
image
Yeah.
then
slash
then
PNG,
recompile when it
then it
stops
expects
the
you,
server.
the
Okay.
But
content
it's not doing that
expects this up
second
here
part,
to
it's
be a
only
PNG
the-
image.
Oh, it's only recompiling. Okay.
But here it's not compiling because it's writing in regular JavaScript.
Not one, sorry.
Yeah, you can use that. Yeah. No, but he asked me if my tool is doing that. No, it's not doing. The watch is only recompiling. You need to add that yourself. But with NodeMon, NodeMon is a solution. There are many others.
Before we take a break, I just want to show you also, of course, now we're just sending a static. I just want to, like, just for fun, we can also just send what is the date right now. So this will take today's date, and then it will convert it to a format called ISO string. Let's just save this, and if we run the server, oh, so something is wrong.
You didn't join them.
Yeah, forgot here. There it is. We load it in the browser. You can see that every time I refresh this page, it comes back with the current time, right? So now you have running Node program, and you can do whatever you want inside that response function. Read out files, or you can generate HTML, or stream video, or do whatever you want. Just gonna see here. We're soon gonna take a break. Okay, so far, just to recap, we have not looked very much at the request object yet, but at least for now, with the response object, you can send different status codes, you can set different headers, and you can send different content back. We're gonna take a break. I think now it's break time, right?
Yeah,
2 o'clock.
it is.
We're gonna take a break. Then we're gonna come back. We're gonna look at the request because we're gonna build a real HTTP server that changes the content when you request different URLs. And then we're gonna talk about how can we turn that into a URL shortener using some of the object-oriented programming we learned, and also with the new stuff we learned about HTTP servers.
Yeah.
Cool. So let's get some food.